Hey guys, got myself a new toy today. It's a Makita rechargeable pen driver drill, model DF012DSH. In the States it's a slightly different in that it comes in a different box. It's a DF012DSE, and the box it comes in is a plastic box like that, which actually I'd much rather than this aluminium box, because these aluminium boxes are always shit. They're just like aluminium thick foil sort of stuff that's just on top of a press board, cardboard stuff, and they always break at the seams after a while and that. Whereas the plastic boxes, as in the picture, seem to be much more rugged. You know, they're just nicer. So I would have liked to get that one, but in Japan we can only get the metal box, so no big deal. It's not going to affect the operation of the driver itself. And where I bought it from Royal Home Centres here in Japan, they actually gave me a bonus battery, a BL0715, which is a nice thing to have. Battery's always going flat right at the last, just before the last screw's finished. So yeah, got a spare battery, so I got two of them, which is a very nice thing indeed. So let's open up this box, see what we got inside. It's just going to be the usual thing. We've got our instructions in Japanese, no less, so I'll probably download a English version. And we got the drill in the bag with the battery pre-installed. Container here with some drill bits. Looks like a 4mm, 3.5, 3, 2mm, whatnot, and some driver bits, and just like some storage space in there, so you can put all your extra parts that you come across. And of course we have the charger. Now this charger's in Japanese, but it looks to be exactly the same as the American model, except they just put a different sticker on the top and bottom there, just for English and Japanese wherever it's being sold. Now this is another reason I don't like these boxes. If you can see already here, look, the dividers are just, they're not even cut nice. Look at that. It's all over the place. It's just, these aluminium boxes are just shit. But what I'm going to do is I'll end up probably just 3D printing some holders and stuff. You see there's a foam insert here for the drill. So the drill was kind of designed to sit there like that somehow. But I'll 3D print some sort of thing to insert here. That will fix all that. I mean, if you don't have a 3D printer, it's not going to help too much. But if you're buying this in America, you're going to get the molded plastic case, which will be a lot nicer inside anyway. So that's, like I said, not much of a bad thing for you guys over the other side of the ocean. So we'll pull this down. I think we might have a look at the charger first, see how that's going. It's a lightweight one, so it's going to be switch mode, as they all are these days. I don't think you get any decent quality power tool that's going to be a transformer. But let's open this up. 4 screws. We'll have a quick look inside, bit of a poke, and then we'll have a close look at the good bit, the drill itself. So the charger is the usual thing. Plug the battery into the top, plug into the wall socket, and it just does its thing. So the model number is a DC07SB. That's probably going to be a different part number for America, because they'll have the English writing rather than the Japanese. But basically you've got the different functions. Got the status LEDs down here. We've got a 2-core figure 8 flex, which I'm not a big fan of. Coming from Australia, I would rather see the double insulation. That wouldn't pass in Australia, but it does in Japan, because Japanese electrical safety standards are rather loose compared to other countries. But you get what you get, and yeah, it'll work. Now, it says it's a PPE on the bottom here. That's a plastic type. I'll hold it up. Maybe you can see if I get the light just right. And then over here it says PPE on the top there. That's the plastic that is used is actually a polyphenylene ether, and it's a thermoplastic, high temperature and high strength. I think it's good to about 215 degrees. That's Celsius. But the stability of the high temperature and the high impact resilience of the thing actually degrades with time, and it's a little bit hard to work with bit hard to injection mold and whatnot. So they mix it with styrene, which kind of makes up for any bad points about the plastic. It kind of fills in the gaps, so to speak. So if it says PPE, it's often going to be PPE plus styrene, or they'll also put the glass fiber in there. It's got no percentage markings on the outside, so I don't know if it's going to have the glass fiber. It's just a charger. It doesn't need to have any crazy strength. So yeah, they use this stuff mainly because well, it's cheap. It gives a nice finish. It's high temperature and high strength, high impact strength, and it's got good dimensional stability. So if you've got parts you need a good tolerance on for fitting together and whatnot, this is a good plastic for that. So we'll pull this thing apart. Oh yeah, it's this one says it's 100 volts. Doesn't say it's dual voltage. 43 watts, 50 to 60 hertz. Japan actually has both frequencies, depending if you're north or south of Japan. 7.2 volts output at 3.6 amps, and it's a lithium charger. Yeah, lithium ion, 7.2 volts. So let's pull this thing apart, and I can probably, if that will fit in there. That won't fit. I was going to use the I was going to use the electric driver, but it won't let me get in there. Oh, maybe nah, that won't. Let's see what happens anyway. If I can figure out how to use it, I'm going to unlock it. There we go. Oh, I did get in there. Awesome. I'll give it a bit more torque. Nice. I'll get them out of the way, and this should just come apart. There we go. Now what do we got inside here? Just some serial numbers and molding dates and whatnot. Nothing too special. And then here's our board. We'll go through the general gist of how this works. So you got your power comes in, goes through the fuse. You got MOVs and whatnot here. That's just some surge suppression, capturing any surges so they don't blow the rest of the circuit up. We've got a little common mode choke here. Our noise filtering capacitor here. Another common mode choke. This is to stop noise coming out of here, because this is switching at high frequency and it makes a lot of electrical noise. And to comply with EMC standards and whatnot, they put those chokes in and the capacitor to filter out any of that noise. Then we've got our bridge rectifier. There are 4 diodes here. Full bridge rectifier. Through the smoothing capacitors, and then you got your DC coming out into the rest of the circuit. After that, we got a transistor here. This transistor will be switching at a high frequency to turn that DC into pulse DC at a high frequency, much higher than 50 or 60 hertz, maybe 50 kilohertz. That then is pulsed through the transformer, and because a high frequency means the transformer is more efficient, so for the same power output, you can have a smaller transformer than at a lower frequency. So that's why these can be so lightweight compared to the old, really heavy chargers that had a massive transformer. That big transformer, as big as your fist, only puts out the same amount of power as something like this little one that's running at a high frequency. After that, we're coming out through a that looks like to be, we've got some, I've got a C in there, looks like a diode. That's probably the output diode. Then some output smoothing caps. We've got a current sense resistor just here, a few other switching bits and pieces, and eventually it will come around to the output to the socket. Now on here looks like we got 2 extra wires. You've got the black and the red, which is the positive and negative, and we've got the white and yellow. That'll be either a balanced charging, because it's actually a 7.2 volt. So being 7.2 volts, it's going to have multiple cells, because, well, lithium cells are what, 3.7 volts or 4.2 volts or something, nominal voltages around there. So this is going to have a couple cells in series, and to do that you've got to balance charge them so you don't end up reverse polarity charging one of them, or pushing current through one where it's a bit weaker or it goes over voltage. Kills the lithium batteries quick smart. So this will be doing balance charging as well. That's what a lot of this extra circuitry for. And of course there's our brains right there. This one here is our optocoupler for our feedback, so that it knows it can alter the duty cycle of the transistor here through the transformer altering the duty cycle means you get more average power through, raises the voltage. If it's too high, it'll sense that through that feedback optocoupler and drop it down and keep it nice and steady. Of course, 2 LEDs there for our indicator to tell us what's going on. Alright, well I'm going to put that back together, and I think I should be able to do that. And we'll have a look at the drill, see what's going on inside here. Before I take this apart, I actually noticed, just like the charger, it's got the plastic type stamps on the outside. Seems like they're doing that these days because people are getting more interested about what the things are made of rather than just, it's plastic, it's green, it's blue, it's yellow, whatever. So what do we got? We got TPE, which is a thermoplastic elastomer, basically like the butyl rubber stuff, yeah, the usual overmolding rubber. And the green plastic is a PA6 GF30. Now PA6 is a nylon 6, or otherwise known as polycaprolactam, and just nylon 6 is a high impact strong plastic, and the GF means glass fiber reinforced, 30% fill. So this green plastic, 30% of that is glass fiber. So that's a usual amount that's used in power tools. Alright, let's unscrew this and see what is inside. So inside we've got the battery terminals here. Looks like we've got some sort of speed controller kind of thing. Oh, that might be the sensing for the torque and whatnot. Probably switching the LED, doing some current limiting for the LED and all that sort of thing. This is actually just an on and off. There's not a variable speed on the buttons. It's full speed forward and full speed reverse. The speed is controlled by the gearbox, so there's only literally 2 speeds, or 3 speeds including 0. We got like a metal insert there, and that's where you see the holes where the bearings, or the ball bearings here, lock in, and that's just for the 2 positions, so it clicks back and forth. Nice having the metal insert there because the plastic will wear out rather quickly with those ball bearings, so the metal just means it lasts a lot longer before the bearings wear tracks into that. And this one here, if we can carefully split this one open. Alright, so it looks like got a standard motor there. That's got our LED and then connections through into the little torque switch thingy. Button for the LED, that's just a tactile push button, and when you slide the switch back and forth, it's got a little ramp on there, and the ramp kind of pushes down in one position, then pulls away in the other position. Nice little... Oh, has that got a rubber cap? Looks like it's got a rubber cap on top of it. Must be sealed somehow. Now if I pull the rest of this out... Oh yeah. It's got to kind of mentally note how it goes back together. Okay. The Makita there is... That writing there is all moulded in. So that's done in a 3-part moulding process. You've got the green would be done first, then probably the white. I'm not sure which would be, if it was white or black, but 3 separate parts to make that one piece. Oh, and there's a bit of something that's fallen out. Alright, Planetary Gear Box, as you'd expect. Gear changer there. It just links in or like unlinks certain parts of the gearbox. And it looks like... I'm just figuring this out. Alright, I was having a bit of a look and I think I figured out how this works. So basically you set the torque by turning this dial. Once it hits the torque, if I unwind it, there's actually a little pin here. I think that little pin there pops out at the torque rating, the torque setting that you've set, and will push against the spring. You can see there's a spring in there, and that spring is what sets the torque, because as you wind it in, you're preloading that spring, and it takes more force to push it the other way, like against that pressure. When you hit the torque, whatever you set it to, it jumps, and then this black metal disc will lift and release pressure on that switch. That sends a momentary open and close, or maybe close and open, like it's depending if it's normally closed, normally open. Whatever it does, it sends a signal down to the brains here. This one through all the circuit board, and then that through its smarts just turns the motor straight off. So yeah, looks like it's a pretty simple setup, but pretty effective. The motor is just a standard brushed permanent magnet DC motor. Nothing special there. It's probably an off-the-shelf part from a motor manufacturer made in China. There's a logo there. I'm not sure what logo that is. There we go. Looks like an XD116Y05. Then it's got 629263-5 for those playing at home. After that, working way back, we got a rocker switch with a custom made little top rocker. The base of that would be a standard part. They would go to a manufacturer of switches and say, we want that switch, but we want the tabs at the top to be bent in this fashion, and we'll put the maybe the manufacturer of the switch puts the rocker on, and they got their custom switch. Looks like we got a terminal screws here. That's interesting. They didn't solder that in. It's just like a screw down terminal, but that it's probably easier than putting like plug-in terminals. These can handle a lot more current, and it means that it's easy to manufacture rather than having to try and solder the thicker cables into the circuit board. You just screw them in. Makes a repair a bit easier. Undo those two screws, unplug the control wire plug, and you can replace this whole section. So now we've got a 3mm white LED and our connector for our torque sense switch. Black blob, can't fix it. Oh well. It's probably a little micro in there. Does all the brains, does the pulse width modulation, transistor as well to control the motor. Although this doesn't have speed control, so maybe there's no pulse width modulation, just be a transistor turning on and off. Alright, well, let's put it back together, see how it performs. We got it back together, no missing parts, no leftover parts, and it all works. Which is good because I haven't even used a thing yet, so it would be a bit of a shame if I broke it before I used it. But I didn't. It's all good. Fits in the hand quite nicely. It would be nice if they had some little bumps on the forward and reverse button just at the top and bottom there. Just so you can index your finger a bit nicer, your finger doesn't so easily slip off. But it's a bit of a nitpick. It's pretty easy to use. Kind of digging the bending action. A bit like a switchblade. But yeah, it does work quite well, and like I think I showed before, the torque switch, that torque switch is really good. I like that. Now here's an interesting thing though. I don't know if this is a Australian or Japanese or American or like Western compared to Asian tool size thing, but you see the length of that there. I'll zoom in a bit actually. Okay, so you see the length of that there. That fits into here. Right, perfect. Now, if I was to get my DeWalt impact drill, which I've had for many years, as you can see, this is the one that we rebuilt in the previous video. If I put that in there, it don't fit. It's not as deep. That chuck in there isn't as deep. So I have to use shorter ones. You can see if I line them up, it's a lot shorter. This one here will fit. You can see how it's a little bit longer than the top, but I actually had to grind that down. I bought this one in Japan. It's just like a 1/2" socket adapter, and that fits in there nicely. But I had to grind that down because they're too long. I don't know why because maybe someone can tell me in the comments. But I had some of these. I got these sent over from Australia, the Irwin brand PH2 little impact rated bits. I got some other like double-ended ones like this sent, which were the same brand, and they were long as well. So even in Australia, you get different sizes. Do them a head in. So it works. It goes in. You can turn it, but it just falls out real easy. So it's just a bit of a pain in the bum. Put that one in. That one's a lot firm. A little bit of play in there. Like you don't want it too tight, but yeah, maybe someone can enlighten me as to what's going on there. Why there's two different depths. Maybe my DeWalt is the weird one. Who knows? I haven't used this, but what I'll do is I'll definitely use it. I bought it for racking equipment in the data centers and just generally using as an electric screwdriver. So I'll put it to use and see how it goes. So we're a few weeks later. I've been using it at work. I thought I'd hold off on releasing the video just so I've got long enough to use this thing and see what I really think of it rather than just bench test it. I've been carrying it around with me on the train through Tokyo, going to the data centers, dismantling, removing, installing servers. It's great. I love it. It's a lot lighter than carrying the DeWalt or even the smaller Impact DeWalt that I did the teardown and rebuild of in an earlier video. These things are heavy duty, but it's in the name. They're heavy. This, not so heavy duty, but for doing just screwdrivering, it's a good thing. It's lightweight, it's easy to use, it's small, you can poke into small areas, and it just does the job. Got no real complaints, except for maybe just making these little bits here taller on the side of this switch, just so that if something slides past, it's going to be diverted over the switch rather than turning that LED on and off when you put it in and out of your pocket. Yeah, if I was in charge of the design revisions on this, I would do that as the first priority for the next revision. Another thing that would be nice, like I said, was a ring light on the front, but I don't know if that's a patent or a licensing issue. I did see the ring light on the DeWalt version. Maybe they've got the patents on that, I don't know. But it may be just a design thing where having this rotating bezel makes it a little bit hard to put a ring light on there. I'm not sure, but it would be nice to see that. I don't use the LEDs so much anyway, so for me it's not a huge issue. But yeah, I'd also mentioned having some little bumps to locate your thumb on there. In operation, I found that wasn't such an issue. So yeah, that's really nitpicking talking about that now. But yeah, the main thing is just having something to stop this switch from turning on and off so easily. I also managed to pick up a few extra things. This is a 7.2 volt torch or flashlight, depending on where you are in the world. Just takes the same batteries, plugs in, and is actually really nice and bright. Uses an SMD LED in there. I'll pull the front cover off. We've got the little plastic lens kind of dust cover. Reflector with the SMD LED in there. You can see that there. Aluminium heatsink on the back, and then just the driver circuit in there. Got a nice inductor, a switch. It'll be a constant voltage or constant current or some sort of circuit in there. And on the back, of course, we've got the battery terminal. So that's a pretty nice unit. It's actually an ML704 as the part number. And yeah, it just goes on and off. There's no special functions, which is all you really want if you're working on a job site. You don't have to cycle through high, medium, low, flash, SOS, flash, whatever, just to get to the function you want. It's on and off. You're poking your torch in a hole or your flashlight in a hole to see what's in there inside the wall or crawling down through a roof. On and off, nice and bright, good enough. Simple and compact. Great unit. Also, I picked up a holster. Makita, of course, keeping it all the brand. It's a A-56982, and it fits this perfectly, even with the long bit on the front. I can slide that in, and it goes in there nice. Look at that. All enclosed, nothing hanging out the bottom. Fits in there quite nicely. It's also got two loops on the sides, so if you've got a spare bit, you can stick that in there, and maybe another one on the other side. So you can carry around a few spare bits, different sizes. Nice and convenient there. Strap on the top, won't fall out, and this Makita kind of piece is a strap as well. You see that? I'm going to use that to hold my torch. Pretty cool. Nice little unit, nice and compact. Now, there is one thing I would change on this holster, and that is the belt loop at the back. It's sewn on both sides. Now, that's good for it to be secure. It's not going to come undone on your belt when you're waving yourself around at the top of a ladder somewhere. But I would like to see a stud or two on there just so I can unhook it. That way I can put it on and off of my belt without having to drop my DAX every time. I don't want to have to go through that pain of undoing my belt, unthreading it from my belt loops, and then taking this off and threading it all back on. It's just a little bit of a convenience thing. Not a big issue. The upshot is it's not going to come undone even if you're jumping around. But yeah, that's about the only thing that I have to pick on this. But all in all, what do I reckon? After using it for a while, thumbs up. It's a good unit. I do like it quite a bit. Now, that's it for this review. Don't forget, we've got that Patreon. Keep watching the videos, and we will see you next time.